Hello. So let's get right into it. First of all, you should know what a circle is. If you wanted to draw a circle yourself, you could put a pencil attached to a piece of string, put it in the center of your page, and then draw around that point. And the reason that it draws a circle is, of course, every point away from the center is the same distance away from the center. And that's the radius, of course. So I'm sure you all know that, but that distance is the radius. And that's one of the only things we need when we're talking about circles. We just need the radius normally. That's how big the circle is. But with this subject, with this part of the notes, we also need to know where the center is. So our equation, I don't know if I mentioned that yesterday. I don't think I did. We need the center and the radius. And the center can move depending on what h and k are. Same way that we had a vertex with parabolas, we'll have a center with circles. So let me give you a quick, this is just our parabola. We can move our focal point around, but I'm not talking about that anymore. I'm talking about circles. This circle, for example, has a radius of 5. We can see that. If we look closely, the radius here has a radius, well, the circle here has a radius of 5. And it's centered at the origin at 0, 0. You can see here on the side of the on the left side of the Desmos thing that it says h is 0 and k is 0. If I move this over, look at this. I'll move it over to here, or maybe here. We can see that h is 4 and k is 3. Or to be more specific, h is how far it's been shifted to the x direction. K is how far it's been shifted in the y direction. And that's really all there is to this. We just need to work with those ideas. Notice that the formula has things squared. Really, it only affects radius in this case. And don't forget, radius is how far away from the center you are to the edge. That's pretty much it for circles. Circles are pretty simple. Hi to everyone who came in a little bit late, just introducing circles here. So let's actually get to it. Tom already did examples 1 and 2, all this stuff. I'll just start with some practice. And it says, find the radius of each circle from the equation. Now I'll remind you that the equation was this, x minus h squared plus y minus k squared equals radius squared. That totally tells us what a circle is. If you forget which one comes first, h or k, well, same way that I reminded you with domain and range, h comes before k, x comes before y. So h is always the one related to the x value. So find the radius of each circle. Well, that's very simple. We can see here that this is 100. Our formula says that that term on the other side must be r squared. So in this case, we can say r squared must be 100. And so r is 10. You square root of both sides. So these questions, especially with circles, very, very, very simple a lot of the time. There's not much to them. You can notice here, hopefully, that h and k, I'll just make a note, center here is at 0, 0. The reason for that is there's no h here, and there's also no k next to the y. So we just ignore it. I'm just going to keep on going. I want to get to the good stuff today, which is ellipses. The next example is not in our regular form. You can see we want it in this form. And it's not quite matching it, so we should move the x to the other side. I'll do that. Bring it over here. You end with x squared plus y squared equals 9. And now we can see h is 0 because there's nothing next to the x. K is 0 because there's nothing next to the y. And r squared is this 9. So again, this 9 is actually r squared. So we're just looking for the radius in all these questions. So this is easy enough. R squared is 9. R equals 3 in this case. And once again, we're done. Okay, just one second. Any questions so far? Or is it pretty clear? There's not much to it, like I said. Clear, I hope. I'm going to go ahead and assume it's clear and have you do C. Tell me what the radius of C is. I'll rearrange it for you just while we're working on it. But what's the radius? You should be able to kind of see it.
9.
9. I'm trying to make it as clear as I can because these do get more complicated. But again, this value here is just r squared. So we can write down that r squared is 81, which means that r, the square root of both sides, must be 9. It's not plus or minus 9 because you can't have a negative radius. You have if you have a string that you're using to draw a circle, you either have a string or you have no string. You can't have negative string. You know what I mean? So the distance from the center is always positive, but that won't come up too much. So that's the big idea. Now let's move on and actually get a little bit trickier question here, which is find the center and the radius of each circle from the equation. So look at this. Let's see. Center and the radius. Well, we see x minus 2 here. That's telling us that h, let me write it down clearly. We can see that the center must be 2 and 1. The 2 comes from the one next to the x, just like parabolas, just the exact same way we found the vertex. And then this negative 1 here is where that comes from. So we take it, change the sign, that is where our center is. I'm just going to jump to decimals for a second. That's the same thing as if the center was 2 and 1. So you can see it's moved over by 2, or over by 2, and up by 1, but the same shape. The radius in this case is going to be slightly different. The radius, oh, it's exactly this actually, it's 5. The radius here would be 5. So the radius, you can see that r squared is 25. Once again, if you're not sure exactly where that came from, that's r squared. And r must be the square root of that, which is 5. So that's our two answers, actually. That's our center. That's our radius. These are simple. This is like 3 marks if you're ever given questions like this. Okay? So for 2C and D, they're slightly different. You need to divide first, but not too much to it. So I'll just show you how you do that just to get one done. I'll do the first one. Notice we have a 4 in front of everything here. We don't want these terms. Like these should not be 4. They should be nothing. They should be 1. So divide everything by 4 first. Divide everything by 4. What do you get? Well, you end up getting x plus 1 all squared plus plus y squared. And then 121 divided by 4, 121 divided by 4 is 30.25. Or we can say it stays the fraction. In any case, we have what we need. The center is easily taken directly from this. You should hopefully see that the x value is -1. The y value, what is it? What's the y value of the center now? What's the y value of the center? What's the number next to the y squared here, or inside that squared term? Hopefully you should see that there is no number next to the y. And so it hasn't been shifted anywhere. That's why it gives us 0. The center would be, if the circle's moved over left by 1, but it is not moved up and down at all. So that's where these relationships come in. And again, the radius, what's that going to be? Well, that's 30.32, the square root of that. If r squared is 30.25, sorry, r must be the square root of that, which is 11 over 2, or 5.5. Whichever way you want to call it. Okay? How do we feel about this? On a scale of 1 to 10, I hope it's pretty much a 10, because this is basic. It's basic. It's good. It's good basic, because it means that you can probably do it with very little effort. Okay, so take 1 or 2 minutes maximum and try D. Okay, 1 minute. Take 1 minute and get that done. So I don't know if that was a minute, but it's close enough. The center is indeed 0 and 6, not 0, -6, 0 and 6. R squared here we can see relates to whatever's on the right side. And so it'll be 64/9, or you can use the decimal, it really doesn't matter. Square root of that, well, we can see that the square root of 64 would be 8, and the square root of 9 is 3. So 8/3, or the decimal version of that, I don't really care. It's all basically the same. It is the same. 8/3 repeats, though, so it's nice to take the fraction this time. Okay, so hopefully that's clear to you guys, and ladies, obviously. Excuse me, cat. All right, and we'll move on, because I want to get to ellipses today, which are basically just stretched circles. I hope you all watched Tom's videos. This is actually the second day that I put on for you to watch the circle videos, and I also wanted you to watch the ellipse video. It was quite long, because the introduction can take a while. So I really hope you watched it. If you didn't, you'll be at a little bit of a disadvantage today, just like you always would be, but especially today. So find the equation of each circle from the given information. Okay, well in this case, the center's at 2, 3. That means that our h must be -2 and our k must be -3. If the radius is 4, that means we're just working backwards here. Let me show you where my brain is right now. I'm thinking, well, in order to make the equation has a general form. It has a specific form that we need to match, which is this. Okay, that is our equation that they're talking about. X and Y are always just general. They're X and Y. They stay variables. We need to be looking for 3 things. We need to be looking for -h, or, we can find h and make a negative. We're looking for this one. And of course, we're also looking for the radius. And those are all things that are normally numbers. I've already solved for those. It took very little time to solve for this. H and K I already have. R I just need to square. That's 16. And so I just put all my numbers in. What I get is x minus h. Sorry, this is not negative yet. This is just 2 and 3. 2, 3. So we say x minus h, x minus the 2. And we got our answer. Square it, plus y minus k, so y minus 3, all squared. And then our r squared here is 16. So just to match, this is our h. We subtracted it. This is our k. We subtracted it. If it was negative, we'd make it positive. And this is our r squared. And so we put it in here. So I hope you see that this is very, very logical. Circles are not difficult. We only deal with center and radius for circles. Those are the only 2 things. Okay. For question B, well, before I move on to question B, is there any questions on this that I can answer? No? Okay. Again, I'm going to kind of keep up the pace today because we have lots to cover, especially ellipses. So the center at -3, -5 passes through the point 3, 0. So let me write down what I know. From this, I can clearly see that h is -3. And I can clearly see that k is -5. Those are given directly from the center. Passes through the point 3, 0. Well, I'm going to worry about that in a second, okay? I'll go back to that. I'm just looking at my notes. I made a couple notes before. Let's put out our general equation. Let's put down what we know so far. So we know that we can write x plus 3. We take the h, change the sign. We also know that it's y plus or minus something. In this case, it's plus 5. Square that. And then we need r squared. The problem is we don't have r squared. The only thing we don't have to complete this equation. X and y are allowed to be general. They're allowed to stay variables. R is not allowed to stay a variable. So what are we going to do? I'll tell you. We haven't used this information yet. Passes through the point 3, 0. So let's substitute that. Substitute in the point 3, 0. That means x equals 3 and y equals 0. Let's substitute those values in. See what we get. So we end up getting 3 plus 3 squared plus 0 plus 5 squared equals r squared. And now you'll notice the only missing piece is r, or r squared. We can actually just solve for r squared and we'd be okay here. So this is 3 plus 3 squared. That's 6 squared, or 36. The next one is 5 squared, which is 25, is r squared. So you add those two together, 36 plus 25 is 61. So r squared must be 61. And now we can finish our story here. You know, I'll connect these things. If h was -3, that's why we get this. If k was -5, that's why we get this. Notice the sign changes. Maybe I should include that. Change of sign, always change of sign. And then our r squared, we want this, which is this. And now we can put the full puzzle together. We can make our entire circle equation. So we can say this is x plus 3 squared plus y plus 5 squared equals 61. Halas, we're finished. Okay, this would be a circle whose center is at -3, -5, and has a radius of 61. Well, a radius actually of whatever root 61 is, but that's the big idea here. All right, any questions on that? We're going to move on soon.
No, sir.
Okie doke. Let's keep up the pace. C is basically the exact same thing. You're given the center and you're given the point that it passes through. Normally I would give you time to do that, but for today I'm not going to, because we've got a little too much to cover because the quiz took a little time from us yesterday. By the way, I was happy with the quizzes. I thought they were done well. They weren't done as well as the first assignment, but that's normal. It's a little trickier than the first assignment in my opinion. And I only caught a couple students cheating. I know that a few of you are probably sharing assignments. I can't stop that, but when I do catch it, you get 0. So a couple students got 0 this time. Maybe you knew that, maybe you didn't. But I'm taking it seriously. If you choose to share your assignment with another student, that is your choice and your chance that you're taking. You know, if you play the lottery, you don't win every time. Sometimes you win. This is like reverse lottery. You take the chance to cheat. If I catch you, you win the bad lottery, okay? So sorry for those of you who got 0 if you're in the audience here, but don't cheat. Do your own work. And then D is a challenge question. We'll skip that, but if you want to try it later, you can. I'm going to quickly do the equation question, and then I want to do ellipses. So let's just take a look at what this question is. It says, find the equation of the circle in the graph. Find the equation. And once again, the equation is always, for a circle, this guy. And so we need 3 things. We always need the 3 things. We need to get our h. That's how far away it's been shifted in the x direction. We need to get our k. That's how it's been shifted in the y direction. And we need to get our r, or r squared, whichever one. That's how much it's been shifted in the, well, it's not shifted at all. That's the radius. And this is very easy, okay? Look at this. How much has it been shifted left and right? This much, 3. It's moved left by 3. The center would have normally been right here, but it's been shifted over by 3. So we can say that h is 3. That's how much it's been moved to the right. Now let's take a look and see how much it's been moved downward. We can see that it's been moved downward by how much? By 5. Down by 5. So k must be -5. Not much to it if you understand what's going on. Move it to the right by 3, move it down by 5. It means h is 3, k is -5. And finally, if you know what a radius is, someone tell me what the radius is for the circle. 4. I see 4 in the chat there. It's 4. It's the distance from the center to the edge. You can even count it. 1, 2, 3, 4 spaces. So r is 4. If r is 4, then r squared is 16. So let's go ahead and write that full equation. X minus 3 squared plus y plus 5 squared equals, what's 4 squared? 16.
16.
That's it. That's all we're doing here. This is our final answer. Okay, so if we were to graph that, which I'll do, I'll show you the full question here, but I want to graph it just to prove to you that it is what I'm saying it is. New blank graph. Let me type it out. And you can see that this is the exact function that I want it to be. X minus 3, square that, plus y plus 5, square that. And I've built an equation. I know that this is 16. So I should see that exact graph back. And I do. That is the same graph in every way. So I took a picture, converted it into an equation, and now I just check my answer on Desmos to make sure it's okay, but it should make sense why it's okay. So that's pretty much the whole topic. That's the whole topic for circles. The rest is just practice. Okay, so I'll take a look at them, but I'm not going to do any more examples on circles because they're so basic compared to the rest of the conic sections. So you should get full marks on that if you understand that, if you do the practice. So in the next case, hopefully you've gotten that written down. If you need me to go back, I will. In this case, same idea. Figure out what the center is. What's the new center? Get the radius, you're done. In the next case, graph each equation. Well, there's nothing to it. I'll just do the very first one. Center is going to be at 3 and 2. The radius, I don't need to write that. We need r squared is 16, so the radius is 4. So all I need to do is go over 3 up 2. That's my center. Radius is 4. 1, 2, 3, 4. That's 4. And then I would draw a circle around. Just make your best sketch, okay? Make your best sketch of this. Let's see. Something like that. Now I can kind of cheat a little bit because I've got fancy pen magic going on, but that's the big idea, okay? You can see that it has a radius of 4 or close to 4. In fact, I could have done better. Let me do better. Go up by 4, 1, 2, 3, 4. Left by 4, 1, 2, 3, 4. Down by 4, 1, 2, 3, 4. And over by 4, and now I'll write that circle. Some students, for some reason, write a diamond. You know, students get their radius points and they do this. Oops, you get the idea. That's obviously not a circle. I know that it might seem crazy for students to do that, but I've seen a lot of students do it. So make sure that you make it a nice smooth radius, as if you were holding a piece of string down and then drawing around using that piece of string like we saw before. Okay, so that's 25 minutes. I got an hour left to work on ellipses, which is pretty good. Are there any questions on circles from start to finish?
No, sir.
Okay, cool. I'd just like to know you're alive. Believe it or not, you're my more talkative class. My other class almost never says anything. None of them. It's super awkward. But I can survive. I can make do, you know. Doesn't hurt me. It's just a little bit weird. Okay, let's move on. The ellipse. Now I hope you watched the video. If you didn't watch the video, this will be a lot of information at once. But Mr. Tom, I think, made a very good video for this. So I'll summarize it as best I can, but I can't hit every single little detail like he does, of course not. So first of all, an ellipse. What is it? Well, let me illuminate it for you. An ellipse is basically a circle that has been stretched. By stretched, I mean, well, of course, we can move the center around if we want to. You know, let's move the center to 2 and 4 just for fun. And I can stretch it in the X direction or in the Y direction. So, oops, sorry about that. I can stretch it in the X direction. Let's see if I stretch it in the X direction, what happens? It looks like this. Whoa! It's been stretched along the X axis, so it has something to do with X's. If I stretch it in the Y direction, stretch, 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 it becomes a circle again, and then stretch, stretch, stretch. So we have two things going on. We have a tug of war. something is trying to pull it in the x direction, something's trying to pull it in the y direction. The bigger amount of stretch is called the major axis. Whatever one is stretching it more. In this case, we can see that A is 4, B is 7. B here will be the major axis. That's a term that we're going to use. But the rest of the things are basically the same. We don't need to worry about radius anymore. We're actually worrying about a couple more things. We're worrying about things called vertices, things called co-vertices. Vertices are for the major axis. Co-vertices are for the minor axis, the smaller axis. And then we're going to be worrying about, like before, we're going to be worrying about foci or foci, depends on how you call it. It has two focus points. Just like our parabola had one focus point, in this case we have two focus points. And we'll see very soon how you get all these things. My son is crying. I don't know if you can hear that, but it sounds very sad. Okay.
Scott?
Yep.
How you have the folders in this month? Yeah.
Sorry, this one?
Yeah.
Sorry, what was your question? How did I make the folders?
Yeah, the H and K, A, B.
So all this stuff, if you go to plus here, you can make your own folders and you can turn things on and off.
Okay.
Yeah. So you can, you know, it turns on, it's like layers that you can turn on and off. I'm going to turn everything off about the ellipse and so on. So I can share this this one as well if you want me to share it with you. It's good to understand. So let me recap. The things that are important about the ellipse are the major axis. The major axis has length that's related to A. We always, I know in the diagram I said B could be bigger, A could be bigger. We like to make things easy. A is always the biggest. B is the smaller one. What I mean by that is if you had something like this, x squared over 16 plus y squared over 4 equals 1, we would call this one A. That would be A squared. If we had x squared over 4 plus y squared over 16, we would actually call this one A. Even though it's under the y, it's A squared, even though it's under the y value, it's still called A. And that's our big thing here. So everything else will sort of fall into place. You'll see how this works. But the big things that matter, there's actually 5 things that you need to keep in mind. Let me be very clear. First thing, where's the center? Second thing, what are the vertices? Well, you find them by just adding A to the center or adding B to the center. So the major axis has the vertices. You add or take away A. The minor axis has co-vertices. That's the third thing. You add or take away B. The fourth thing is to find the focal points or the foci. Fifth thing, sometimes we get the eccentricity. So the best way to understand this is through examples. If you saw the videos, you see it follows the same steps every single time. If you didn't see the videos, I'll try my best to summarize it for you. Okay? The general equations we're going to use look like this. In fact, they almost always look more like this than the one to the left. You'll notice that they have x first, usually, but the A can move around. It can be under either one. So you'll either see that form or this form. A is always the bigger value. And then finally, I mentioned eccentricity. It's how squished or how stretched the ellipse is compared to a circle. Or I like to say how weird the ellipse is compared to a circle. So if it looks like a circle, the eccentricity is just 1. If it looks like a crazy stretched out circle, the eccentricity is going to be much bigger or much smaller, depending on it. Let's look at some examples, okay? Example 1 and 2 were already done. Example 3 was also done. Well, actually, example 3 was not done, and I've changed it so that it's a little more interesting, okay? A little nicer numbers and a little better example. So let's start from there. You've got to scratch out what I already wrote there. Sorry, scratch out what the book has and put in the new equation. That's the first thing I ask of you, okay? From here, I'm going to show you how you solve these questions. I'm going to write to the side the 5 steps one more time. 1, 2, 3, 4, 5. The 5 things you need to be concerned with are: where is the center? What are the vertices? That's the points on the major axis. That's the endpoints of the circle. What's the co-vertices? That's the points on the minor axis, the endpoints. What are the focal points, or the foci? That's, you take the major axis but only add a small distance. And then eccentricity is how stretched it is. Eccentricity. Something I didn't note: eccentricity is always c divided by a. That's the formula. And the foci comes from this. C squared equals a squared minus b squared. That's not Pythagoras. That is a different thing. So it'll all come together soon. You'll see what I mean. You're probably saying, sir, what is this? I'll get you through. Don't worry, you'll see what's happening here. So first of all, this doesn't match our regular form. By this, I mean this doesn't match what we want it to be. We want the right side to be 1. So divide everything by 36 first, kind of like we did last time. I'm going to start it over here. Divide everything by 36. What do we get? So 4 divided by 36 gives us 1 over 9. So this one will be x squared over 9. What's 9 divided by 36? 9 divided by 36 gives 1 over 4. It's y squared over 4. And then what's 36 divided by 36? Of course, it's 1. Now, this doesn't have anything special going on with the center. The center in this case is 0, 0. So I'm going to start drawing a sketch. It'll be very helpful later, okay? Based on our equation here, remember it normally has x minus h, y minus k, things like that. Tom already did examples like that. You'll have to go back and see them. This example just has center at the center of the axis. What else do I need? Let me look at my little cheat sheet over here. I need vertices. I need my vertices. How do I get my vertices? I'll tell you. To get the vertices, you need to find A. So first of all, we need to get A. Really, we've been given A squared. Does anyone remember how you get A? Which one of these numbers, 9 or 4, is A squared?
9.
9.
9. Okay, good. You're paying attention. It's always the bigger one. So that's 9. It's the bigger one. That's just, we just steal it. We steal the bigger number, that's it. So now we can get A easily. A must be 3, sort of like what we did with the radius before. Now we can get the vertices, and I'll show you how. Vertices. How do we get the vertices? Well, you'll have to listen carefully because this is very much a mental exercise a lot of the time. Think about it this way. The A value is grouped up with the X. That means the major axis, because this is A, the major axis must be along the X axis, the X direction. And so we go left from the center by A and right from the center by A. So in this case, we know where the center is. It's right here in the middle. Go over by 3, 1, 2, 3. That's the major axis direction. It's related to X. And left by 3, 1, 2, 3. Major axis direction. Those are my vertices. Those are my endpoints of what this ellipse will be. It's going to look, by the way, it's going to look something like this. The ellipse will be stretched like this. But I don't know exactly what way yet. So I can write those down. I know I have 2 vertices, 1 for each side. -3 and 0. And 3 and 0. Let me write them down on top of each other so it's very clear. So 3 and 0, -3 and 0. Okay. Most of what else I'm going to do is pretty much the same thing I just did, but in a different direction. So just a quick recap. I forced it in the right form, the nice equation. I found which one was the bigger one on bottom. That must be A squared. Solve for it. Solve for A. And then whatever one that's related to, X or Y, that's the direction I need to go in. So in this case, it's related to the X. I went in that direction. If you're still not sure exactly why, well, you can notice that this is a distance of A, And this is also a distance of A. Okay, that's how I got my vertices, or my vertexes, 2 vertexes. What am I going to do next? I have A. I think I'm going to need to get B. B is related to my co-vertices. So look, I've done my center. I got my vertices. Now I need my co-vertices that are related to the minor axis, in this case, the vertical. So B squared. Let me make this crystal clear here. This 9 must be A squared. This 4 must be B squared. The smaller one. B squared in this case is 4. So B is the square root of that, which is 2. Okay? So it means that from the center we went over each way a radius of 3. It's like a radius. And then for the B, I'm going to go up 2, down 2. So my co-vertices, I like to draw the picture first and then figure it out. So I need to go up 2 from the center. That'll be one of my co-vertices. And then down 2 from the center. That'll be my other co-vertex or co-vertices. Now I've got the full picture, almost the full picture. I can make my ellipse now. It looks like this. Not perfect, close enough. Let me just draw it like a student would because I don't want to feel like I'm cheating. So make a nice smooth curve here. As smooth as you can, no diamonds, okay? And that's not perfect. It kind of looks like a sad little, I don't know, jelly thing, but it's an ellipse. It's supposed to be symmetrical. And then I'm going to write how I got my B there. This distance is B, yeah? B. This distance also B. I'm not going to write all those things every time. I'm just trying to get it into your head the first time. So by looking at our diagram, co-vertices is the major axis. Sorry, vertices major axis, co-vertices minor axis, smaller axis. Minor means small. What are my co-vertices? I've got 2 of them. You can look at it right from my diagram. You can see what they are.
It's 0, 2, and 0, -2.
Perfect. Okay, thank you. That's exactly what they are. You should see the vertices are further apart. The co-vertices are not as far apart. That's why they're major and minor. It's why they have the definition that they do. I'm just going to quickly label them. This is my vertices. This is my co-vertices. I also need my focus, or my foci. That comes from C. How do I get C? I wrote the equation earlier. C squared. So just seeing a question here. The one close to the center is the CV. Yes. You'll notice co-vertices are related to B because B is the smaller number. Vertices are related to A because A is the bigger number. So back to this point, C squared is A squared minus B squared always. The reason I'm getting this is because C gives me the focus. Just like P, the P value for parabolas yesterday gave us the foci or focus. Now our foci are going to be given by C. So C squared, A squared we already have, it's 9. B squared we already have, it's 4. We could steal it right from here actually. 9 minus 4, that would give 5. That means C must be root 5. You can write the decimal if you want. I'll write the decimal next to it in case you want to write it that way. It's up to you which one you choose. So 2.24. Okay, hopefully you're with me so far. That's my C value. That is the distance along the major axis, just like the vertex. Distance along the major axis that I need to move out. So it's going to be, what's 2.24? It's about right here and right here. I like to color code it because otherwise things get lost. So my foci, my 2 focal points, my 2 focus points are 2.24 or root 5, whichever one you want to use, root 5 and 0, negative root 5 and 0. And I'm going to write the eccentricity, then I'll answer questions. Eccentricity, E is just C over A. So E is root 5 over 3. And let me just box these all in. This might seem like a ton of work, okay? I understand it might seem like a whole lot of work. And honestly, it is a long question. There's no doubt about that it's a long question. But the nice thing about this is, if I ask you this question where I want the coordinates, they're always done the exact same way every time. Ahmed, you said, why is there no focus for the co-vertices? It's because there is only a focus for the vertices. It's just the way it is. So we don't need to worry about the co-vertex. We just go along the major axis. Any other questions on this? We'll do another one like it. We'll do a few like it, actually. Probably 2 or 3 if you want.
Sir, I have a question.
Yes, tell me.
And the equation, the 4x power 2 is x here. Why we put it in y power 2? The 4x. And the 9y power 2. We change here in this equation x power 2 over 9. And in the equation, it's 9y power 2.
Yes, so let me show you. Maybe, I think I know what your question is. In the beginning, look at this. Okay, this is 36, yeah?
Mm-hmm.
Our general equation, if we look up a little bit, our equation should always have 1 on the right side. So in order to get that 1, we needed to divide everything by 36.
Ah, okay.
So if you divide this by 36, you get 1. You divide this by 36, you get, it becomes 1 over 4. You divide this by 36, you actually get 1 over 9. And that's why you get a 9 there and a 4 on the side with the y.
Okay.
Was that your question? Is that what you were wondering about?
Yeah. That's my question, yes. Thank you.
I guess I can keep that there. There's no harm to that. Any other questions? We'll do more examples. Don't worry, Ahmed. Just more examples time. I'm assuming you all got it written down. Going once. Going twice. I feel so bad. My child hasn't stopped crying since we started this lesson. Maybe he just hates the math. I don't know. I don't think you can hear me though. Anyway, hopefully you can't hear it because it's very distracting for me. But if you can't hear it, that's good. All right, I'm going to move on. And again, I'm going to follow these steps. The same 5 steps, depending on what the question is, of course. Some sketching. Tom did these. I'm going to move on. The summary notes are very helpful. I just want to summarize them. I like bring them up. The center is always HK. If you have H and K given, just steal it. Everything else is the same. A squared is always the biggest denominator, so the biggest number on bottom. The next, say, the orientation of the ellipse. So the shape of the ellipse is just found by looking at whatever is above A squared. So if X is above the biggest number, then it's going to be stretched in the X direction. And if the biggest number is below the Y value, it's going to be stretched in the Y direction. So that's why I said if X is above, it's going to be horizontal. If Y is above, it's going to be vertical for the major axis. And finally, the foci, I don't need to read the rest. The foci, really, you find it based on this. The value of C tells you how far to move along the major axis. So when Ahmed asked me that question, this is why. It's saying that the foci are only found for the major axis, not the minor axis. And it's from the center to the foci. Okay, so let me summarize something. Vertices, center plus or minus A. Co-vertices, center plus or minus B. Foci, center plus or minus, what do you think it's going to be? C, but it's major. So this one's major. This one's minor. This one's major. That's the big idea. And by center, I mean, of course, if you had to add it, if the major axis is in the X direction, you got to add it to the X. If it's in the Y direction, you got to add it to the Y. We'll see that. But I'm just trying to keep it as simple as I can. And if you understand it even at the base level, you should be okay. You know, it's better to understand than to memorize. I always would say that. So hopefully that's clear. You can always go back and take a picture of that, look at it on the YouTube video, whatever you need. So let's do some practice. Find the coordinates of the vertices and the foci for each given ellipse. It doesn't ask for eccentricity here. If it did, we could give it. Vertices here, it actually means vertices and co-vertices because they're both vertices and then both foci. All right, so allow me to begin the tale. Here, first of all, before I even start, I know this ellipse will look like this. How do I know that? Because the bigger number on bottom is touching the x, so it's stretched in the x direction. The number here on bottom, that's just a 1, so it's actually smaller. So let me start building this for you. Sorry, I'm just getting my notes. So let's start building this. First of all, I know that my center is 0, 0. How do I know that? Because there is no h or k here. If there's nothing next to the x, there's no h. If there's nothing next to the y, there's no k. Let's go through our story. A squared, what's a squared? It's the bigger number on bottom. In this case, 4. That means a must be 2. I can get my vertices. But I'm going to draw a picture first, because otherwise, I'm just going to confuse myself. So some of you don't like to draw pictures. I would respectfully recommend that you learn to draw the picture, because it's going to help you so much. The center here at the middle, okay, at the crossing, 0, 0. What are the vertices? Well, it's the x. X is the major axis. This is under the x. So under the x squared term. It's stretched in that direction by 2. So it's like a radius in that direction. Go over by 2. Over this way by 2. Over that way by 2. Both ways. That gives me the vertices. I can just look at it and figure it out. It must be 2, 0. And negative 2, 0. Okay? Done. I can see it. This is 2, 0. This is negative 2, 0. I move on, and I find B. What is B? B is found by B squared. I wasn't given this number. Yeah, Ahmed, you got 1. I agree. B squared is 1, which means B is the same thing, actually. Square root of 1 is still 1. And that gives me co-vertices. I'm going to go up from the center by 1 and down from the center by 1. So I'll write that on my little sketch. And that'll tell me what my vertices are. So it must be 0, 1 and 0, negative 1. Okay, hopefully you're following. It's the exact same process as I did last time. I can already sketch the shape, so I'm just going to make a little sketch. Again, doesn't need to be perfect, but don't make it a diamond. Make it a rounded shape at least. Pretend that it started as a circle. What do I need next? Well, I have my co-vertices and my vertices. I need my foci, so c squared. What's the equation for c squared? It is not Pythagoras. It is a squared minus b squared. A squared and b squared are both given in the question, actually, or you can look at it here and here. You don't need to take a and square it again. It kind of would be a waste of time. So it's 4. Let me color code it so you can see. 4 minus 1. And get the square root. So c squared must be 3. So c is the root of 3. And what's root 3? Root 3, that is about 1.73. So I'll put it right there. Kind of hard to see. It actually doesn't even ask for the sketch, so it's not a big deal. I just made the sketch to help you out, but we can move on and get foci now. So what is the foci? Someone tell me what the coordinates of the foci are. Remember, it's a distance c from the center along the major axis direction. And there's 2 of them.
0, 3.
Say again?
0 and root 3.
It's along the major axis.
Root 3 and 0.
Root 3 and 0.
Yeah, remember the first one is x, so we go in that x direction. when you go in that the other x direction.
-3, -√3.
Okay, so negative, I know it's tricky. If you wanted to convert it to a decimal, you can. You could use 1.73, and then you would go 1.73 to the right, 1.73 to the left. And this is done. Look, we've got the vertices, and we've got the foci. If it asked for the ellipse, it didn't. Sorry, if it asked for the eccentricity, we would just divide C by A. So it would be √3/2, which you might recognize, I don't know, √3/2, that's 0.866. So a perfect circle is a value of 1. The smaller than 1 it is, how squished it is compared to that is how weird it is. So it's been squished by about 86. It's 86% of a circle now. It's been squished down. We have everything we need. We're done the question. Vertices, co-vertices, foci. This is our recipe. This is our steps. The first few times it probably is a lot of thinking, but not so bad once you get into it.
Mister,
Yep.
we take the foci from the x-axis because the bigger number is under the x.
Yes. And if that 4, if that 4 here was under the y, we would actually go in the y direction. It would stretch that way.
Clear.
Yep. So I'd like you to try B. I want to know what your vertices are. You can just get, even if you just get the vertices and co-vertices, give it a try, okay? I'll start writing my solutions under it, but I want to see if you can manage the steps. The steps stay the same every time, like I said. So 2 or 3 minutes on that, okay? Maybe until 3:00, let's see, 3, what time is it now? So it's 3:07. Let's come back 3:07. Okay. And again, it didn't ask for the eccentricity, but if it did, it would be 0.6, so it's very squished. So you'll notice I did a little bit different with the terminology just this time, just so you can choose which one you like. Some students don't like to write down vertices every time because it's a long word for some of you. You can put V. There's two sets of V values, two sets of vertices, two sets of co-vertices. So that's excellent. Ayesha, you got the right stuff. Tarek, it looks like every single one of your answers was correct. And I think that's basically it for what I saw the answers that came in, but this is the big idea, yeah? No tricks. No tricks yet. Excellent. So Ayesha, don't forget the co-vertices. You can get vertices. In fact, it's actually a pretty good idea to get vertices and foci together because that's both major axis things. And then you can get the co-vertices after if you want, but it's just personal preference. I like to go A, B, C because the alphabet is pleasing. All right, any issues on that? Point 6, that's the eccentricity. It wasn't asked for, but if it did ask for it, eccentricity. It's the kind of stretch. It's like how stretched it is based compared to a regular circle. So in this case, it's 60% of a regular circle. It's been squished by 40%. All good? So once again, let me just quickly, I'll just quickly show you what this looks like. Make a new graph. If I was to graph this, x squared divided by 100 plus y squared divided by 64 equals 1. This is a circle, but it's 64% the size of a regular circle. You know, a regular circle would look like this. I'll just put the 100 on the other side. We'd have a standard radius of 100. We can see it's been squished. So actually the 64% thing wasn't so accurate. 60% thing wasn't so accurate, but you get the basic idea. It used to be, it's almost like the circle used to be the blue one. And then we're saying, let's make it an ellipse. Let's just squish it down just a little bit. And we end up getting the ellipse. That's the big idea. You feel okay with that? Got half an hour left. Still got more to do, of course. If you need to stop me at any time to explain anything, I will. See, the only difference, I'm not going to do the whole thing. I'm going to just show you the very first step. There is clearly a problem with this. It should be 1. The right side for ellipses should always be 1. So divide everything by 144. That should give us x over 16, sorry, x squared over 16. 36 divided by 144 gives 1 over 4. And that gives 1. And so on. I'm not going to do the rest. You can try that on your own and actually make that homework if you choose to do it. Of course, the practice that you do is all up to you. But every single practice problem in this course is fair game, except for a couple that I'll note. And so on. I'll just put etc. I don't want to do that one because it's the exact same as ones we've done already. I do want to do the next one, okay? Because the next one is actually the first one we see where y is the major axis. And I don't want you getting it in your head that the major axis is always the x. It just depends on what the equation looks like, okay? We're going to change the form first. What does that mean? I need to get it into its ellipse form. I'm going to expand it first, multiply, multiply. Y squared equals 16 minus 8x squared. I'm going to keep the number on the right side, move the x to the left side to get it closer to what I expect. It's looking pretty good. That's not quite right because I need to have a 1 on the left. So what do? I need to divide this now by 16. 8 divided by 16, a half. 1 divided by 16 is, of course, 1 over 16. And now, ladies and gentlemen, we have a ellipse that will look more like this. Okay, that was a terrible example. But it will be stretched vertically, not horizontally. And it all comes down to this guy here. That is our a squared now. The other one next to it will be our b squared. Remember, a squared or a is always our biggest one. All right, so let's go through the motions again. Let's do the whole thing again. What do we got here? I'll just start writing up here. A squared is the one under the y now, the bigger one, 16. So a is 4. I'm just going to get all the numbers out of the way. B squared is 2. That means b is root 2. C squared is 16 minus 2, a squared minus b squared. That means that it's root 14. Wait. 16 minus, sorry, 1 second. Yeah, okay, yeah, I was right. 16 minus 2, root 14. Can root 14 be simplified? 7 and 2? No, neither one is a perfect square. So I've got those three. Now I can get my vertices from this. I recommend you just go ahead and try it yourself because, I mean, the steps are the same every time. I'm just going to make a little sketch down here. My center is at 0, 0. A is 4 and B is root 2. So I go up by 4, 1, 2, 3, 4. Down by 4, 1, 2, 3, 4. Remember, it's A is related to the Y. That's 4. So right away, my first vertex will be 0, 4. The second vertex will be 0, negative 4. That's different. That's different. Be careful with that. It's not what we saw last time. But you should know why. It's because our Y direction is our major axis. Root 2, what's root 2? Root 2 is, I think, 1.414 or something. 1.414. So that's our minor axis. In other words, the smaller axis. And so 1.4 is about here. You don't need to be perfect. I'm just drawing the sketch so that you get the idea. And now we have enough information. Again, I'm not a master of drawing ellipses. I'm just drawing it for sketch purposes. That means our co-vertices. Think about this carefully. The center is at 0, 0. I have to add the b to the y, the x values. So the co-vertex here must be root 2 and 0. I've added to the x values. The other co-vertex, minus root 2, 0. Same exact steps as before, just adding and subtracting to the different axes. And then our foci, focal points. I add that to the major axis. Once again, the major axis is the y, so add to the center, up by root 14, down by root 14. And finally, if it asked for eccentricity, I want to write this just in case. We see over A, which is root 14 over 4, which is 0.935. Just in case, so I want you to be prepared if it's asked for it. I don't know if it will be or not. I don't have a test created yet. Okay, how do we feel about that? Any questions?
No, sir, all good.
Okay, good. You'll see it has like maximum 5 steps normally. There are more questions we need to cover in the next 15 minutes. Well, maybe more than 15 minutes. I want to make sure that the basics are covered. These are the basics. So once again, 5 things. I'm going to say it again because it's so important. And if you understand what each piece is, you'll have no trouble with the rest. Center, H and K. Vertices, which you add to the major axis. You get it from the major axis, from the center to the major axis, the final, how big it is. It's like a radius for the major axis. Co-vertices, it's like a radius for the minor axis, depending on what the A value, B value are. Focus, the distance from the center to the focus on the major direction. And eccentricity is how squishy it is, how far away it deviates or is different from a circle. That's the big idea here. And we've done the same thing about 3 or 4 times now. And if you watch Tom's videos, you've seen a lot more. So I hope it's clear or getting clearer. Let's go to the trickier questions. Practice 2, I've said this first one's for homework. It's very basic. I'll do B. Once again, same story. We just need to, I'll just do one example, I think, because these are kind of all very similar. This is on page 21, by the way. Okay, B. What do we got? Center. First things first. What's the center? The center is 0, 0. Sometimes it's not 0, 0. That's why I keep considering this. Before we start, before we go any further and actually make the graph, what will the ellipse look like? Will it be a stretched out ellipse in the x direction, or will it be a stretched out ellipse in the vertical direction?
In vertical direction. Why?
It'll be vertical because the major axis is related to the A, or the bigger number on bottom, which is attached to the y axis, or attached to the y squared. Okay, so that was good. That's excellent. That's what I was looking for. Let's go through the motions. A squared, oops, turn that off. A squared is 81. A bigger one, always, for ellipses. It means A is 9. Covertices, B squared is 49, the smaller one. What's the root of 49? It looks like a square number, but it's, so it is a square number. Yeah, 7, of course. C, foci. That's the last piece that I need. C squared is B squared minus A squared. Wait, A squared minus B squared. 81 minus 49. What is 81 minus 49? It is 32. Root 32 is 4 root 2. Feel free to write it as a decimal. It makes 0 difference to me. Sometimes when you're graphing it, that's easier. So 5.66 if you want to use the decimal. Okay? So before we do anything else, we can start sketching. Again, I'm keeping up the pace. I hope you're following along. The center in this case is at 0. A is in the y direction. So let me be clear. So let me just say y direction. This is in the x direction. So go up by 9, down by 9. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just fits. And down by 9. Over by 7 in both directions. 1, 2, 3, 4, 5, 6, 7. And 7. If I miss one, please tell me. Like if I go off by 1, tell me, because I'll just be making a mess for everybody. And that's enough. That's my major axis and my minor axis. So let's connect them. Don't make a diamond, please. Make an egg, or whatever you want to call it. Try to make it as rounded as possible. Oops, not sure what happened there. I think I have a special function on my pen that I haven't used before. Okay, close enough. I mean, I'm left-handed. I kind of ended up doing a bit of a weird thing there, but good enough. Hopefully that's clear. You can see the B is the minor axis. The 9 is the A is the major axis, going up by 9, and so on. If you forgot anything or missed anything, just rewatch the video later. 5.66 focus is along the longer axis, the major axis. So 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. It's about there. And 1, 2, 3, about there. Now, I know some of you don't have the notes printed in front of you. I've said this already, and I meant it when I said it. You should definitely have at least a notebook, and you can sketch this. There's no reason you can't sketch this. But if you're going to do it to scale, you should at least have some graph paper. I don't know who it was when I was marking your assignments. One of you marks on graph paper, but your graph is a square, rectangles. So be careful with that. Your ellipse will be all out of proportion if you use that. But anyway, you're expected to know how to graph this is my point here. Okay, so I think I'm done. I just haven't noted what my actual coordinates are, so let's do that. My vertices. What are they? They are in the y direction, 0, 9, 0, -9. Co-vertices. Sorry, that's a little bit ugly. Probably ugly all the time, but I'm doing my best. 7, 0, -7, 0. And finally, focal points or foci, whatever way you want to pronounce it, they're all the same. That's along the vertical axis, 0. And then for root 2, it's just from the center to the focus directly, add C. And -4 root 2. That's our final answer. I'm not going to put those in boxes. I feel like it's just making a mess. That's it. That's everything I was asked for. Anything I need to clarify?
No.
Going along okay, hopefully. I hope you see the pattern. It's pretty much the same each time, which I said already. The next questions are the only ones that break the pattern. But again, I wanted to do enough of these examples so that when you get to those questions, you understand the concept well enough that you can handle them, okay? And we're just going to do a couple of them. These questions here that I skipped, like A, do it for homework. The only way to get better at this is to work through it yourself. Same one here, homework. I don't want to go through it again because honestly, we've done it. We did one almost exactly like it. The only thing I'll say is if and when you do this question for homework, make sure you divide it by 144 first. When you do that, you'll get, I might as well give you that. It'll look like this. Okay, equals 1. And then you move on. It should have a shape, when you finish, it should have a shape that looks like this because this is related to the x. Okay, so let's go on and finish this. We've got 15 minutes left. I think we're going to make it. We're going to make it. I was a little worried in the beginning, but I think we're all going to be okay. So practice 3. We've got this and then the next page. This one's very fast. Find the equation of the ellipse when we given information. Again, we need to fit it into this form. I'm going to write this down so that no one is confused what I'm trying to do here. This is the form of an ellipse. Don't forget your A and B, of course. In this case, where is my A going to be? Is it going to be under the X or under the Y? Well, it's going to be under the X because it's stretched in that direction. Okay, so let's have just a couple notes on it. Let's make a note of what we know about this function, or what we know. We need to get H. We definitely need to get K, given from the center. And we need to get A and B. And if we have those 4 things, we can write the equation as it's meant to be. So the center is clear. We can get that directly from the diagram. In fact, we can get everything from the diagram. Where is the center? Well, if we look at this here, if you look carefully, you've gone over by 5 and down 1. So it's 5, -1. I don't feel like I need to explain that anymore. I think you should know that from when we did circles. I'll just make it clear. Center, right 5, down 1. That's it. What about A? What is A? A is the distance from the center to the major, to the vertex. On the major axis, the distance from the center to the vertex.
4.
1, 2, 3, 4. Yes, it is. A equals 4. So A is 4. I don't need A. Really, I need A squared. So I might as well get it now. I'm looking over here. I'm going to eventually need A squared. So A squared is 16. So I have that piece. What about B squared? Well, I need B first. And B is the length of the minor axis. That's just 1. I can see it from the diagram. It's just 1. So I can square that and get b squared. That's an easy one. That's just one. I'm actually finished. If you look at this equation up here, you needed h, k, a, and b. H, k, a squared, and b squared. So I can write our final answer. What I'm going to do. So h minus 5, remember change the sign, over a squared, which is 16, plus y, change the sign on the center value, plus 1, over b squared is 1. So I don't really need to write it there, but there's no harm in keeping it there. And of course I need the square. So you can write that, but really I probably should have just deleted that 1 out. Same thing. So this is kind of our full answer. It'd be better to skip to that, if I was being honest here. Because there's no reason to write a 1 on bottom. Every number has a 1 on bottom. Okay, anything I can review there? Notice that the foci, are not part of the equation, so we didn't need them. They're not helpful. Any questions at all?
No.
Okay, I'm not going to stop asking because it is important to me that if you did have questions, at least you have a chance to ask them. Sometimes I can go on forever.
Sir, I have a question.
Yes.
Do we need
okay.
the radius here?
No, because A and B are pretty much the radius, right? It's like the radius of the major axis and the radius of the minor axis. But radius, if you the word radius means the same all around, and we only have radius for circles.
Ah, okay.
Okay, great. Thanks for that. Okay, so that one's finished. B, skip. The numbers are way too weird. It's too complicated. You'd have to be guessing. It doesn't make any sense. So just you can skip that one. But we will try. Which ones? C and D here. C, Tom did one like this, and D, sorry. C, Tom did one just like it, and then D is fresh. So let's see what we have here. This is the only kind of question that requires, I would say, extra thought. So you can't follow the same recipe. You need to figure it out, okay? So let's write down what we're given. Center at 0, 3. So center is 0 and 3. I know it's written right in front of me, but I want to make sure it's crystal clear. That means that H is 0 and K is 3. Again, just making it crystal clear. I usually put them in a highlighter, so why not? Let's just highlight them in case we need them later. What else do I need? This is, just to be clear, the question is asking what is the formula? You know, what's the equation? This is about as good as we can get. We know we have something on bottom here. We know we have A or B squared. Need to be in here, but I don't know which one, okay? So we need to figure that out, and then we can throw them in. So it says we have a vertex at 12, 3. Notice I changed them. There's a typo, so just switch those. A vertex at 12 and 3, and a focus at -4 and 3. I'm going to draw a picture. I'm going to draw a picture here so that we can be clear. It's just a sketch, but without a sketch, I find it's very difficult to understand what's going on. So I'm going to put my center on it first. That's at 0, 3. 1, 2, 3. My vertex is at 12, 3. So over 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3 up. It's my vertex. My focus is at -4 and 3. 1, 2, 3, 4, -4 and 3. Okay. I've color coded those. Hopefully you can see what they are. Maybe I'll just make it clear. F, C, V. believe it or not, that is enough information for me to solve this question. Because given the center and the vertex, I can get A. Because A is the distance from the center to the vertex. Not the co-vertex, but the vertex. And the distance from the center to the focus is C. If I know C and A, I can get B. So let's go step by step, okay? First step. Let's try to get A. We know from this diagram, or I know from the diagram, and I hope you'll learn, A is this distance. Okay, it shouldn't be a snake, my bad. A is this distance. A in this case was 12. If you look at the diagram, it's from 0 to 12 is 12. So A is 12. That means A squared is 144. By the way, we know what formula we're trying to match this with now. We know that because the focus and the vertex are in this direction, we know that because of our sketch, A squared must be here. And B squared must be here. Okay, you can hopefully see how all this stuff is connected. What do I do now? I know that this was under X. What do I do now? What can I do? I need B. How am I going to get B? B focus plus A. Well, I don't add A to the focus. Focus actually has nothing to do with A. Focus has everything to do with C. And so Tarek, you're saying A squared minus C squared. Let me see if you're right. 2. I know that I have a focus, and focus is related to this, A squared minus B squared. I need B squared. And so B squared actually is, let's see, A squared minus C squared, which is exactly what you said. So congratulations. 1 extra thumbs up, 2 thumbs up for you. I can't give bonus marks because people yell at me, but I can appreciate your effort. Okay, so B. What is B? A squared minus B squared. So B squared is, what's A squared? 144. What's C squared? I didn't talk about what C was yet, but that's the distance to the focus. C is 1, 2, 3, 4. It's 4, so 4 squared. Let me write this clearly. I know that C must be 4 here. Yeah? Probably should have said this earlier. C squared is 16, so minus 16. Hopefully I didn't confuse you there. I didn't think ahead well enough. So 144 minus 16, square root of that is 8 root 2, if I did this correctly. But I don't even need to get the root because I'm looking for B squared anyway. So 144 minus 16 is 128. Okay, so to recap, in order to figure out the equation, I needed to know what A squared and B squared are. I know what H and K are, that's easy. A, I get directly from the diagram. C, I also got directly from the diagram. And so they can both together give me B, or B squared. Now I can write my final equation. So let's do that. My final equation is x minus 0. Okay, I won't write it. Just x squared. Over A squared. What's A squared? 144. Plus y minus k. Well, that must be y minus 3. Square all that. B squared. B squared is 128. So I'm just stealing from my previous answers here. Equals 1. Actually, I'm done. That's my final answer. So I have a couple minutes left. I'm going to try to get partway through D at least. It's a little trickier. Anything I can explain for that?
No, sir. Okay.
Well, you can always go back and watch the videos. I'm not too concerned because you've got this on tape, on videotape, as my father would still say. So you're going to record that on videotape? It's like, Dad, you have an iPhone. Anyway, so center, -1, -2, and 1. I'm going to try to go through this one as quickly as I can, okay? First thing you should do is sketch. Tried to write sketch and I failed. Sketch. Okay, what do we have? The center at -2 and 1. 1, 2, up 1, center right here. Vertex -2 and 5. So 1, 2, 3, 4, 5. That's my vertex. So right away it's telling me that my ellipse must look like this, up. And that means that right away I have my A. It's this distance, which is 4. I can see that from my diagram right away. So I'm going to write that down. A is 4. That means my A squared that I'm going to need is 16. Okay, I'm halfway there already. The problem is it gave me center and vertex. So it gave me this weird one, passes through this point. We did something just like that for the circle question. So let's see what we can do here. Let me just trust me for a second. I'm going to write out what I know. So x minus h, or x plus 2, again, from here, over a squared, or over 16, plus y minus 1, again, that's from the center, over b squared. We don't know what b squared is, but we do know that it equals 1, and we've been given a point. What we're going to do now is substitute in 0, 1, just like our circle question. Put in x equals 0, y equals 1. And this will start to fall into place very quickly. So replace, oh, did anyone catch my mistake? The a here should be under the y squared. By definition, the a needs to go over there. So I need to switch these places. Sorry about that. I've done 100 of these and I still sometimes get things backwards. Okay, and now we solve. It's actually quite simple. I also forgot the squares. This is what happens when I'm thinking about other things. So x plus 2, we're going to put in x equals 0. So 0 plus 2, square that, over b squared, plus, what's y? Well, y is 1. I'm substituting in 1. Over 16 equals 1. If you solve all this, you know, this cancels out because 1 minus 1 is 0. 2 squared on top is 4. So what we end up with is 4 over b squared equals 1. Sorry, I'm rushing. I want to get this finished. B must equal 2. And you can check that after if you don't believe me. Hopefully you believe me. We really need b squared though, so let me just make it 4. Okay, now we have a squared, we have b squared, we can write our final equation. So we did this. First step, second step, third step is substitute, fourth step is to get b squared, fifth step really is to write the final equation, and I'll leave you be. X plus 2 squared over b squared is 4, plus y minus 1 over a squared is 16, equals 1. Dun, 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 dun. Okay, I finished. Sorry I had to rush at the end there, but I didn't want to go late. You know, take a picture of that or watch the video again if you need to. I hope it's clear. They won't get any harder than that question, okay? We've
Sorry,
covered.
forget the power 2 again.
Did I forget the
The
power
power
2?
2.
I'm so glad you're all still awake. It's helpful. Again, too much in my brain. Okay, thank you, everybody. I'll stop the recording here. Bye-bye, everybody. See you next time.
Can